faster these particles move, the more dangerous they are, because faster means just more energy. We could see aurora in Ladakh, in Hanle. There's a telescope there, so people there have reported that you could see aurora in Hanle also.
Anything that happens on the sun and that is very strong, then it affects the atmosphere, ionosphere of the earth, and it affects our technological life. If there is a direct solar coronal mass ejection towards the earth, then obviously we have to a little bit worry.
Solar flares, this is very common. It happens all the time. It just so happens that the sun is it's getting to the peak of its activity. It's 11-year cycle. Every 11 years, the activity of the sun goes from high to low, and in 2025, it is going to peak. So, the chances of more solar flares coming out in this time is more, but it's not very uncommon thing. Now, the reason why this is coming to into the news is that this flare, which came out of the very active solar spot region on the sun, I think 3664. I don't know, I have to check that number. So from that is a very active region of the sun surface, and this solar flare that came out, it is ejected from the sun surface. Matlab, it is coming out from the surface of the sun. It is thrown out highly charged particles of plasma. And these charged particles can travel at very high velocities. Anything it can take from few hours to few days to reach Earth. It can be that fast also. So the faster these particles move, the more dangerous they are, because faster means just more energy. Now what happens when it comes to the Earth? Earth has a magnetic field. Earth has an atmosphere, right? So since these are charged particles coming from the sun, they can be deflected by the magnetic field. And because they're deflected by the magnetic field, most of these charged particles go around the Earth. But some of them can come to the polar regions of the Earth. And they interact with the gas molecules on the upper atmosphere, and they produce plasma. And that is why you see a color. It's called aurora. Aurora Borealis in the northern hemisphere and Aurora Australis in the southern hemisphere. Now the thing is that solar flares are never very strong. And these aurora that is caused by the flares can be seen only in the polar and Arctic regions. Matlab, northern Europe and in the bottom in the Antarctic area. But when there's a very strong solar flare like the one which happened yesterday, it's supposed to be a class 4, means it's very high. Now this is, and unfortunately Earth also is in the path of the solar charged particles coming from the sun. Now this, combined with our magnetic field and our atmosphere, produces the aurora. And people are very fortunate to even see this right up to northern Italy, which is very down in the latitude. Usually you see it only above Norway and Iceland and all those ways. But now we could see it all the way to Italy. And I also read in the news that we could see aurora in Ladakh, in Hanle. There's a telescope there. So people there have reported that you could see aurora in Hanle also. Now talking about how does it affect us. For a common person, It does not affect because flares come and go, auroras come and go. It never affects us any health-wise or environment-wise directly. But what it can affect is our day-to-day life, that is communication. We have so many satellites that communicate, that take our signals up and down. That can be disrupted. Your TV, satellite TV signals can be disrupted. Your radio communication can be disrupted. So these things are the only side effects of solar flare.
Strong emission of X-rays and ultraviolet radiation from the sun. This is X-ray flare that NASA has spoken about. And X-ray flares are associated with large sunspots on the surface of the sun. So right now the sun is passing through its strong phase of its activity. As we know that sun's activities has a 11-year cycle. So right now the sun is passing through the peak of its activity. That's why we are seeing repeatedly many sunspots on the surface of the sun. So sunspots have very strong magnetic fields, and because of that there is a sudden release sometimes of energy. That energy is in the form of X-rays and ultraviolet radiation. So that reaches the Earth and it causes disturbance in our ionosphere. Because of that, radio blackouts may take place at short wavelengths. Say, one blackout has been noticed lasting about an hour's time at 30 megahertz frequencies. So, this is a normal thing every peak time of the solar activity, and sun is passing through this since billions of years. So there's nothing to fear about or worry about. But one thing is that now, because it's our technological life, so anything that happens on the sun and that is very strong, then it affects the atmosphere, ionosphere of the Earth, and it affects our technological life. For example, there are satellites in orbit around the Earth. They are at the heights of, say, 400 to 700 or 800 kilometers. So they are actually in a very thin ionosphere. So as radiation from the sun comes, it affects the ionosphere, and because of that, there is a slight heating up of the atmosphere, and there is an increased drag on the satellites. Right now, its positioning is such that it is somewhat looking away from the Earth. So if there is any coronal mass ejection, it's something like it's going to be something like a grazing incidence only. So we shouldn't worry at all. But if there is a direct solar coronal mass ejection towards the Earth, then obviously we have to a little bit worry, because, for example, there can be a power outage. So the power grid companies will take due care in that matter.